So the teacher is explaining, oh class, this is the edge, this is the vertex, and this is the face. Students reacted, that's fine, but you haven't told us the most important part. What's in it? Yes, guys, today that's what we're gonna learn. What's inside the prism, what's inside a solid figure. We talk about volume. Volume of a cylinder, a cone, and a sphere. We distinguish between a surface area and a volume. We know the surface area is simply the outside. Look at my fist. This is the volume. The outside is the surface area. Surface area is just the outside that covers the solid figure. But we want to know the exact size of this, and we use cubes to measure it. How many small cubes are there in this big cube? That's what we call volume. So these are the four major formulas that you need to know. The basic or the general formula is volume equals the base times the height. We learned this before. Whatever your base is, just multiply it by the height. The area of the base, just multiply it by the height. Then that's the volume of your solid figure. A cylinder is pi r squared times height. For a sphere, it's a volume equals 4/3 pi r to the third power. And for a cone, it's 1/3 pi r squared times height. These are cylinders in real life. You see this in your house. You see these all around you. For example, a can, a crayon, a paper towel, and a lot more. But remember, this is called the radius. And this is called the height. These are the two things that we will use when we solve for volume. Now, the volume, as we said, is base times height. The circular base, a circle, is pi r squared. That's the area below. If you multiply it by the height, simply just write times h. Therefore, the formula is pi r squared times height. In this case, the radius is a 3 and the height is a 10. Let's follow the formula. Radius is a 3. I plug in 3. Height is a 10. Take note, radius is not the diameter. So 3 squared will be a 9. Bring down your 10, bring down your pi. Then I could multiply. It's easier to multiply first the whole number. So 9 times 10 is a 90. Leave the pi at the end. Pi would be next, 90 pi cubic meters, but it says round to the nearest hundredths. Therefore, I need to use my calculator. Do not round your pi value. Calculator times 90, you will get a non-terminating decimal. Since it says nearest hundredths, will the 3 affect my 4? No. Therefore, it ends at 4. Retain the place of 4. So 282.74 cubic meters. Remember, the unit is now cubic and not squared. Another example. Obviously, from the drawing, we could see this is the radius and this is the height. Plug it in, radius squared, height over there. So 4 squared is a 16 times 12. Multiply this first, but it says answer in terms of pi. Therefore, after multiplying 16 and 12, I get 192. I leave the pi there. There is no need to multiply by pi because it says answer in terms of pi. These are real-life examples of cones. This is a traffic cone. Some are geometric shapes used in math. Some are things you see around your house or in your classroom. So remember again, in a cone, we will be needing the radius. And we will also be needing the height. The height here, remember, is the perpendicular height, not the slanted height. Not the slanted height. It should be perpendicular 90 degrees from the base. Before we get the volume of a cone, let's derive the formula. There are a lot of videos about this, but we'll keep it short. If you make an experiment wherein given the same height and radius, same height and same radius of a cylinder and a cone, put some water in your cone, pour that water in your cylinder, guess what? Naturally, it won't fill up the whole cylinder. It only fills up, look at this portion, that's only 1/3 of the cylinder. So the volume of a cone is 1/3 of the volume of a cylinder. Let's write that as a statement and let's make our formula. So the volume of a cone is 1/3 the volume of a cylinder. Remember our formula a while ago? We wrote pi r squared times height. Since I only need 1/3 of that, simply write down 1/3 pi r squared times height. Or you could just write over 3. Let's use that formula for this example. The drawing will give you 3 different numbers, but I said you should know which numbers to use. Obviously, that's the radius. Check this out. Will I use 3 or 5 as my height? Ooh, remember, it has to be in 90 degrees from the ground. I'm not going to use a slanted height. No way. I'm not going to use you. I'm going to use 4. Therefore, if you know the formula, simply substitute. So 1/3 pi, our radius is 3, and our height is not 5. Remember, it's 4. I substitute 4. Now we're ready to solve. 3 times 3 is a 9 times 4. 9 times 4 is a 36. Divide by 3 and times pi, you will get a non-terminating decimal once again. There are different ways to do this, guys. You could multiply 1 times pi times 36 divided by 3, or multiply 1/3 of 36, which is 12. 12 times pi, you'll get the same thing. But it says here, round to the nearest feet. Therefore, I want it to be a whole number. Will the 6 affect my 7? 5 and up, round up. Yes. Therefore, my answer is 38 cubic feet. What is the volume of this cone? Another example. Which height will I use? Which radius will I use? Formulas make your life easier. So substitute it. The radius is 4. And yes, I won't use 6.4. I'm going to use 5. There you go. 4 times 4 is 16. I plug it in. See how I show my work? You have to show it step by layers. Even if you can do it mentally, it is a good habit to write it down. 16 times 5, I multiply that and I get an 80. You could multiply now. 80 times pi, then divided by 3. No rounding it. 80 times pi, then divide by 3. You will get another non-terminating decimal. Since my instruction is round to the nearest hundreds, tens, hundreds, it stays here. Will the 5 affect my 7? 5 and up, I round up. Therefore, 83.78 cubic feet. Next, these are spheres in real life. My basketball is a sphere. All right. So it's a sphere is 3D, a circle is 2D. Now, again, we will use just one measurement, the radius. Okay? So the formula, I won't derive this formula. There's another video that would explain how we derive this formula. Okay? So let's just jump to the formula. 4/3 pi r cubed. Take note, this is cubed, not squared. So, substitute the radius of 12. I plug in my 12. That becomes 12 times 12 times 12. I get... Then, look at the steps here. You could multiply 4 times pi times this, and the whole thing divided by 3. Okay, so multiply the top numbers first, then divide by 3. So, that's going to be 21,714 point non-terminating, the rest, and then after that, divide by 3. So when I divide by 3, it's still a non-terminating decimal, but my instruction says nearest centimeter, meaning I want a whole number. Will my 2 affect my 8? No. Therefore, my answer is 7,238 cubic centimeters. Now, try this on your own. 4/3 pi r squared, obviously its radius is 7. Always look at the drawing. If the drawing here is the whole thing, they're giving you a diameter. You know how to change a diameter to a radius. You split it by 2, divide by 2, because I only need this. So we're lucky it's already a radius. So 7 to the third power is 539. Then, again, multiply all the top numbers. 4 times pi times 539. Then the whole thing divided by 3 at the end. Do not do the rounding yet. When I divide, it's still a non-terminating decimal. It says nearest tens. Tens is over here. Will the 5 affect the 7? Yes. So that becomes 2,257.8 cubic centimeters. Now, these are examples for you to practice. Just pause and answer on your own. One more. One more. That's it. Bye.